Alright, taking a look at surface area. I'm exhausted from the volume. Surface area, whenever you're thinking about it, you're sitting there wondering, okay, well, what is the big deal about surface area? Why do I need to know this? If for some reason you were some sort of like present wrapping fanatic and you wanted to conserve as much paper as possible, or you're thinking about painting a box, or you're thinking about painting some type of cylinder or any type of prism, you can actually know how much paint or paper that you would need to cover it. So when you're finding surface area, it's just finding the area of every single side and adding it up. But there's formulas that can help you do that, and they're a little confusing, but I always advise finding the total surface area for every single shape that you possibly can. And the reason is, you can see here with the lateral and the total surface area formula, they both have the same thing in it. pH, pH. Capital P means perimeter of the base. And from the volume video, we know that whenever we're finding, I'm going to use the bottom this time as the base, because rectangular prisms, you just have to find a set of parallel sides. And rectangular prisms have all rectangles, so it's not hard to do. And then on the triangular prism, obviously it's going to be the triangle. That's why it's called a triangular prism. So what the capital P means is finding the perimeter of the base. This is where you're sitting there going, you got to change gears and go from area to perimeter. So if we had a 5 by 7 here, that means the other side's 5 and the other side's 7. So finding perimeter just means how far around is it. You just add up 5 and 7, 5 and 7. So capital P, I break all this stuff down and then I put it all in the formula together. H, and then 2 times capital B. And we know from the volume formulas that capital B means area of the base. So perimeter is going to be 5 plus 7 plus 5 plus 7. It should give you 24, because 5 plus 7 is 12, and then you have another 12, so that's 24. So capital P is going to give you a total of 24. Nice. I don't have to think about that anymore. Capital P is taken care of. Height is going to be the distance from your base to the other base. So I'm going to go ahead and highlight the top. And I mean, I do this on my problems whenever I'm going through, because I like to define where the bases are for me. That way I don't have to think about the pieces and find them over and over and over again. I drew that red up and down arrow to separate the bases, to show you that from the bottom to the top, that the height of this rectangular prism is 3. So 2 times the area of the base. Okay, so why 2 times the area of the base? Well, that's why I highlighted 2 of them. Because you're going to find the area of the bottom and the top. And what you just did with the P and H was you found all the sides going around it. You found the area of all those and you added them up. 24 times 3 will be the area of all of those combined. Then we're going to add the area of the top and bottom, which is the area of the base. 5 times 7 is 35, and then times 2, because we have 2 of those, so 70. So all those parts are laid out. Now all you have to do is use the formula. I highly advise using total, and you can find lateral from that just by using the first part. So I'm going to highlight lateral in green. There's lateral. And then I'm going to highlight the total, or the bases, in this blue. So you can see that when you put them together, you get the whole thing. But if you just wanted to have the lateral, you would just take off the bases and give you all the sides. So capital P times height plus 2 times the area of the base. Look at this. I got all this stuff defined already. So 24 times 3 plus 2, or I already did that, so time plus 70. So type it in the calculator. 24 times 3, 72. So 72 plus 70 will give you 142 square units. And notice that surface area, and area always uses square units because we're not adding depth to this. So 142 square units. Let's take a look at the triangular prism. And we're going to go through the same process. So this is where you're going to start using those numbers on the slanty sides of the triangles. Go ahead and highlight this back base here so we can define the height of the triangular prism. All right, so P, perimeter of the base, height of the prism, and then 2 times the area of the base. Let's go ahead and figure that out. Let's add some numbers in here. 5, 5, and 4, and let's do 10. All right, and the height of the triangle. See, you can see there's a lot more numbers now. We're having to use all of them. Surface area is, you just have to be really organized. So let's use 6 as the height. All right, so perimeter of the base. I'm going to highlight the perimeter in a yellow. So we're looking around the outside of the triangle, and we should end up getting 5 plus 5 plus 4. Thinking logically about the perimeter of a triangle, we know that we're going to be adding up 3 numbers because there's only 3 sides. So that's why there's a 5, 5, and 4. If you're sitting there adding up 4 numbers or 6 numbers, it's like triangles don't have 5 or 6 numbers. They don't have 5 or 6 sides. So 5 plus 4 should give you 14. That's our capital P. Awesome. The height, so that's the distance from the front to the back. Separating the front and the back by using this black line with 2 arrows on the ends. That way I know, okay, from the distance from the front to the back is 10. It's the height of your prism. So whenever we went over volume, we had to find the area of triangles. That's your capital B. Capital B is going to be the area of the triangle, which is base times height divided by 2. The base of the triangle is where the right angle sits, or where it makes the B. So 4 times the height, how tall the right angle is, 6 divided by 2. Area equals 24 divided by 2, which is 12 square units. So now we have 12 as the area of the base, but we have 2 of those. We have a 12 here and we have a 12 back here. So times 2 equals 24. So just to emphasize how the formula is working, we've got in green is going to be your lateral, which would be the sides. That'd be the 3 rectangles that connect the triangles. So take the bases off and you have 3 triangles connecting. It'll look like a tent with the ends open. That'll be your perimeter of the base times the height. And then in the blue will be the area of the bases. And whenever you add those on, it means you get every single side. You found the area and you added them all up, which means total surface area. So let's plug all this stuff into the formula. I'm going to keep writing total. I'm going to keep finding the total. Capital P times H plus 2 times the area of the base. 14 times 10 plus 24. So that should be 140 plus 24, give you about 164 square units. Remember, surface area, area squared, square units, little tiny squares. We don't have depth, so we can't have cubes. Cylinders, reviewed in the volume video when we had to talk about the volume of cylinders, differentiating between a radius and a diameter. Diameter is a longer word, diameter is a longer line, radius is a shorter word, radius is a shorter line. So whenever you want to find it, you just cut the diameter in half and you've got the shorter word and the shorter line. Cylinders, you can see that when we're looking at the formula for total, that it carries the same rule as it did with the prisms. That first part before you add on the 2 pi r squared, keep in mind that pi r squared is the area of a circle. So the reason you have that multiplied by 2 is because you got a top and a bottom. They're both circles. So when you multiply that by 2, if it's 50, then you have an area of 2 circles that are 50, which makes it 100. The 2 pi rh, it ends up being a circle, but if you were to like snip it in half, it ends up being a long rectangle that's wrapping around the circle. So whenever you cut that, it ends up being just a length and width. but since it's going around the circle, you have to find the circumference. So that's why that looks really weird. I'm going to go ahead and just start breaking down the problem. I'm only going to solve it with 5 and a height of 10, and I'll go over the diameter part and how that would work the same. So the formula is 2 pi radius times height plus 2 pi radius squared. All right, that looks like it's almost impossible, but whenever you just start rewriting it with the stuff that you know, 2 times 3.14, you know the radius is 5, and we know that the height is 10. I highly advise you solve the first section and then solve the second section. Don't type it all in a calculator at the same time. You're going to run into some mistakes and you're not going to know where you messed up. 2 times 3.14 times 5 times 10. 314. That worked out nice. All right, plus. Now I'm going to add in this second part right here. 2 times 3.14 times the radius squared, because I'm finding the area of the circle. That's what the r squared and the pi have to do right there. And since I'm multiplying it by 2, I'm going to find the area of both of those that I just highlighted. And then the radius is 5 squared. So 2 times 3.14 times 25, 157. So we end up having 314 plus 157. Gives you 471 square units, because we're talking about only covering the outside. So what I'm going to do is I'm going to go back and I'm going to highlight the lateral surface area, which would be the rectangle that's wrapping around it, all the way around those circles. I'm highlighting it in green. And that would also be the 314. I'm also going to highlight what the area of the circles were, which is your 2 pi r squared. 2 because there's 2 bases. That would be your 157. And then the total is because we added up both of them. We added up the lateral, the sides, plus the bases. We got 471. Here's how that process would change if you had a diameter instead of a radius. If you said that your diameter was 10, so these cylinders are identical. But to get a diameter to turn into a radius, you just cut it in half. So half of 10 would be 5. Cool. Now we can start solving the problem. Just to provide another example of diameter, just to be thorough, if the diameter were 20, what do you think the radius would be? Half of 20 give you a radius of 10. That's as difficult as that gets. Cylinders seem complicated, but if you solve it one piece at a time, it works out really easy.